1.5 Solving quadratic equations. So we're going to recall quadratic functions can either have 0, 1, or 2 x-intercepts. Okay, and a quadratic relation in this form, so this is the vertex form, has a vertex of hk. Okay, so how does 0 x-intercepts look? This occurs when a and k have the same sign. So essentially, if their vertex lies above the x-axis and a is positive as well, it opens up, and if k is negative, then the vertex lies below the x-axis, and then the parabola opens down. Okay, so in these two situations, we have 0 x-intercepts. Okay, when does 1 x-intercept occur? This occurs when the vertex lies on the x-axis. Okay, so lies on the x-axis and opens up, or lies on the x-axis and opens down. Now, 2 x-intercepts occurs when a and k have different signs. So when k is positive, the parabola will lie above, and then a would be negative, so it would go through the x-axis. And when k is negative, the parabola lies below the x-axis, and then a would be positive, so it would go through. Okay, factoring and solving. So when we talk about solving for a quadratic equation, this means to find the x-intercepts. Okay, so x-intercepts are also called roots. We can do this in a number of ways. We can factor. We can use the quadratic formula. We can complete the square, or we can graph. Okay, so solving quadratic equations by factoring. And so this tells us that we need to find the x-intercepts. We need to start with the equation in standard form, okay, so completely expanded. And then to find the x-intercepts, we sub in y equals 0. We fully factor, and then what we have is, we have, for example, y equals something in a bracket times something in a bracket. Let's just call this a and b. Well, we know that if either a or b equals 0, then this entire expression equals 0. So that's what we need to do. We need to branch these two off, equate them to 0, and then solve for x. Okay, and again, roots or solutions, these are values that make this true. ax squared plus bx plus c, when does it equal 0? Okay, so for example 1, we have an equation, and it's already in factored form. So let's branch these down, okay? So y is going to equal, or this equation is going to equal 0 if x plus 5 equals 0, okay? Or when x minus 8 equals 0. So we can go ahead and rearrange, and we get x equals negative 5 and x equals 8. Okay, just bringing that negative 8 over. Okay, so there are two situations in which this equation here, x plus 5, x minus 8, will equal 0. Okay, so a lot of the times for a lot of individuals will just if it's x plus 5, they'll just say, okay, well, minus 5. And that's fine until you get to a situation like b, where you actually have to rearrange and solve. Okay, so we can't just say, oh, negative 3. We actually have to bring that over, and I agree that it's 2x equals negative 3, but now we have to actually divide out that 2. So we get x equals negative 3 over 2. Okay, so a little bit different when we have to rearrange, but we're still taking this factor and equating it to 0. So bring the negative 2 over, we get 2, and then divide out that 5. We get x equals 2 over 5. Okay, example 2, find the roots of each quadratic equation by first factoring. So, what two numbers multiply to 14 and add to 9? Okay, so 1 and 14, 2 and 7. Yeah, 2 and 7 add to 9. So this factors to x plus 2, x plus 7. Now we can branch these off. So I'm going to do the quick way where, because the coefficient here is 1, like 1x plus 2, we won't have to divide out. So I'm just going to put x equals negative 2. And this is going to be x equals negative 7. Okay, and for b, b only has two terms. One's an x squared term and one's an x term. So we can actually common factor. And we can common factor 2x out of this. So we're left with x plus 2. Okay, so when we branch these off, I'll do the x plus 2 quick. X equals -2. Okay, but we haven't seen 2x equals 0 yet. Okay, a lot of individuals put 2 but that's wrong, because what happens is when we take the factor 2x and we equate it to 0, even if we divide out the 2, we get x equals 0, because 0 divided by 2 equals 0. Ready? No. Okay, so for C, we can see that this is difference of squares. We can square the first term and we can square the second term, and there's also a negative sign between them. So, what is the root of 25x squared? Well, it's 5x. And what is the root of 4? Well, it's 2. So we know that we can factor this by doing 5x plus 2, and then 5x minus 2. Okay, now this is one of the situations where I would actually branch off and equate both factors to 0. Okay, just so that we don't make a mistake, bring over the 2, we get 5x equals -2, and divide out the 5. Okay, so for the first factor, we get x equals -2/5. And then for the second factor, again, 5x minus 2 equated to 0. Bring over the -2, 5x equals 2, and divide out the 5. So we get x equals 2/5. Okay, and the last one here. We need to put this in the standard form of a quadratic equation. So let's bring over the -7x and the -6. So we have 2x squared plus 7x plus 6. Okay, so the first term is 2x squared, so we don't have a coefficient of 1. So we have to find a number that multiplies to 12, because it's like 2 times 6. Okay, and then adds to 7. So factors of a 12, 1, 12, 2, 6, 3, 4. Well, 3 and 4 add to 7. So what we do is we do decomposition on that middle term. So instead of writing it as 7x, we write it as 3x plus 4x, and then just bring down the 6. And now, because we have 4 terms, we do factor by grouping. Okay, so what can we factor out of the first 2 terms? Just an x. Okay, so we get x, and then we get 2x plus 3. What can we factor to the second two terms? Just a 2. So plus 2, and we're left with 2 plus 3. Sorry, 2x plus 3. Now, if we have two terms, we can do a common factor. For these two terms, the common factor is 2x plus 3. Okay, so the common factor goes out front, 2x plus 3, and then we have x plus 2 is left over. Okay, when we equate both of these to 0, this one we rearrange and we'll get negative 3 over 2. And then this one, because the coefficient of x is just 1, we can just do x equals negative 2. Okay, quadratic formula. So when we have a situation where maybe we have decimals or numbers that we can't really factor nicely, what we can do is we can use quadratic formula, and it never fails. You can even do it with quadratic equations that are very nice. And what we do is we sub in the coefficients a, b, and c to the quadratic formula, and we can find the zeros. Okay, so let's do the first one. Solve the following using quadratic formula. So our a will be the 2, our b will be the 6, and our c will be the negative 10. Okay, and you have to make sure that you put the negative on there. So x equals negative b, so negative 6, plus minus the square root of b squared, so 6 squared, minus 4, a is 2, and c is negative 10. Okay, all over 2a. Okay, so usually what I do is for that, the first simplifying, I simplify the entire expression under the bracket. So 6 squared minus 4 times 2 times negative 10, I get 116. So negative 6 plus minus root 116 over 4. Okay, now we can branch these off. So we have x equals negative 6 plus root 116 over 4. And then we're also going to have negative 6 minus root 116 over 4. Okay, and when we put this into our calculators, okay, for the first one we get 1.19, and we can of course round this. It's not going to be a nice number. And for the second one we get negative 4.19. Okay, let's do B. So our A is going to be negative 5, our B is going to be 6, and our C is going to be 8. So we have x equals negative b plus minus the square root of b squared minus 4. The a is negative 5 and the c is 8. All over 2a, so 2 times negative 5. Okay, again, put this entire expression under the brackets in your calculator. I get 196. So I get negative 6 plus minus root 196 over negative 10. Okay, and then we can branch these off. So we know x is going to equal negative 6 plus root 196 over negative 10, and x is also going to equal negative 6 minus root 196 over negative 10. Okay, so negative 6 plus root 196 divided by negative 10, I get negative 0.8. And I get 2. Okay, this should be a recall of grade 10, but we're going to touch on discriminant. So the discriminant is the name given to that expression in the quadratic formula under that root sign. So the discriminant is b squared minus 4ac. So we use this just like this short form to determine the number of real roots. So this is not to actually determine the roots, it's just the number of real roots that the quadratic relation has. So if the discriminant is greater than 0, what's going to happen is we're going to be able to branch off. So we're going to have like the two answers, just like we recently saw. Now, if the discriminant is less than 0, can you root a negative number? No. So there's actually 0 real roots. Okay, and when the discriminant equals 0, well, when we root 0, we just get 0. So there's not going to be a branch off. So there's just going to be one real root. Okay, so without graphing, what we're going to do is we're going to use the discriminant to determine the number of real roots that each one of these has. Okay, so we set this up the same. A equals 2, B equals -7, and C equals 10. Okay, so all we have to do is sub it into b squared minus 4ac. So we have -7 squared minus 4 to 10. Okay, and what we get for this one is -31. Okay, so since the discriminant is -31, therefore, because d is less than 0, there are 0 roots. Okay, so for the next one, a equals 4, b equals -7, and c equals -4. So let's sub that in. We get -7 squared minus 4ac. Okay, and when we calculate this, we get 113. Okay, so since d is greater than 0, we have 2 roots. Okay, and the last one, a equals 2, b equals 4, and c equals 2. Okay, so we sub in b squared minus 4ac, and we get 0. So since d equals 0, we get, there's 1 root. Okay, and example 5, identify the x-intercepts of the following graphs. So we have two parabolas here, both of them open up, which is fine. They can open up or down, doesn't matter. Okay, so when we look for the x-intercepts, we're looking for where the parabola actually crosses the x-axis. So here we have x equals -5, and here we have x equals 4. Okay, for b, we have x equals 0, and we have x equals 3.